No, I want to thank Balchem for the kind invitation to be here with you today. And again, Tri-State, it certainly is one of the premier dairy conferences in the U.S., and so it's great to, and a lot of that is not only for the program, but also, those that attend, right? So it's a great thrill for me to kind of catch up with a few of you anyway in the short time that I'm kind of here for this whole thing. So we're going to kind of continue on, and I'm following one of the young hotshots anyway in the whole world of nutritional physiology and metabolism with Heather's program, and she obviously outlined for you very nicely maybe what some of the opportunities here may be from a biological standpoint. I'm going to focus in a little bit more and just really talk about what we know anyway from the literature about feeding choline and methionine in transition cows. And again, there's an inherent reason why we, to some extent, think about those two things in somewhat the same conversation. I think you'll see that clearly there are some distinctions there and some important distinctions there, et cetera. So the other thing I was doing, and this was partly as Grummer was talking, but really not in response to Rick, was to kind of tuck a few slides in here just up front, just to kind of, I felt inspired to get opinionated. How's that? So I'll kind of throw a couple things up here and we'll kind of go from there, right? This is a slide that I probably should give Drakely $1 for every time I've used it, but again, just depicting the overall relationships here between adipose tissue metabolism in terms of release of NEFA into the bloodstream during periods of negative energy balance, and also what happens relative to, again, these NEFA taken up by the mammary gland, incorporated in milk fat. NEFA, again, as Rick very nicely outlined, are an important fuel for tissues of the cow, especially muscle, during that post-calving period as she spares glucose for lactose synthesis for the mammary gland. So again, a key homeoretic adaptation that's an important adaptation to lactation is, again, the role of NEFA as fuel sources for the cow. And of course, the NEFA are also taken up by the liver. The data that we have would say that roughly 20% or so, maybe up to 25% of the NEFA that the liver sees, it pulls out of the bloodstream, right? And the NEFA then can either burn these NEFA either basically fully to CO2, partially to ketone bodies such as beta-hydroxybutyrate and others in the mitochondria. Also, there's peroxisomal oxidation as well in the liver of that cow, especially in that periparturient period. And again, if not oxidized, they're re-esterified into triglycerides, and they're exported out in the blood as VLDL, and again, can be used then by a variety of tissues or stored as fat, okay? So the dogma, right, or at least commonly held thoughts, right, are that ruminants are prone to fat accumulation in the liver because of high mobilization of NEFA and inability of liver to adequately metabolize them, okay? And I would say certainly elements of that are absolutely true, and certainly mobilization is a risk factor, right? Certainly of NEFA, but just because the cow is mobilizing lots of body condition and has higher concentration of bloodstream doesn't necessarily destine her that she's going to have a fatty liver, right? There's regulation that happens. And again, I think that's part of one of the things I want to kind of point home here. The other one I pulled out of a quote, I actually left the author's name off, but this was from a paper published in 1993 in Journal of Dairy Science. It was one of the foundational papers relative to fatty liver and lipid-related disorders. And the author, his hair is as white today as it was then, and he's from the University of Wisconsin. So with those clues, you can put that one together. But anyways, certainly a major factor contributing to development of fatty liver dairy cows is a slow rate of triglyceride export as VLDL. And again, Heather touched on this certainly as well. Now again, part of that's comparative, right? So again, ruminants don't, there's some aspects of ruminant fatty acid metabolism that dictate they're just not wired the same way to export triglycerides into the bloodstream. Again, the liver is not a major source of fatty acid synthesis, unlike monogastrics. And again, but just because of this doesn't mean that there's not some modulation there that we can think about, okay? And then finally, high NEFA leads to high blood ketones and maybe vice versa. And again, I think that's somewhat of a commonly held belief anyway, okay? Just going to key, again, Heather alluded to this. She talked about the liver as being roughly 20 pounds, and these are data actually from some work that Chris Reynolds had done a number of years ago now, showing, again, wet weight of the liver. He put it, actually these data from 2 different studies. The challenge is it's hard to weigh the liver more than once during the transition period, right? So this is from slaughter data. Again, cows slaughtered at different times, and so, you know, yeah, right? I mean, you can only measure it once, pretty much. It's hard to pull it out and put it back. Anyways, and what you see here, though, is from days relative to calving, in this one data set here where they actually had the mass of the liver, it doesn't really change appreciably, right? Certainly in response to feed intake going on to lactation, liver mass will increase to some extent, but you don't have a meaningful change in liver mass, I would say, during this time frame, okay? Conversely, though, Chris also measured, and this he did do on cows repeatedly during this transition period, measured oxygen uptake, really as a proxy for energy energy metabolism, and you see again essentially this doubling of oxygen uptake post-calving compared to pre-calving. And we could do a really, really amateur crude thing and just divide moles into kilos, and you can say roughly per kilo of mass, that liver really ramps up what it's doing. And I think that reflects anyway what we know about, you know, the increase in glucose synthesis and of course obviously increased fatty acid metabolism as well, and different things that we have in that cow as she goes into lactation. Okay. Now, a few years ago, I used Chris's data as well, and what I did is I calculated the actual NEFA uptake by the liver during the transition period. And again, this thought that, boy, this liver takes up these fatty acids, and she basically stores them as fat, and yeah, you get a little bit of metabolism otherwise, and it's just kind of the way it is. What's interesting is when you start to look at this on a gram per day basis, and Chris had actual measured data here from day minus 19, minus 9, 11, 21, 33, 83. Okay, the star is here on day 0 because I calculated that, I predicted that based on NEFA concentrations in the blood at around the time of calving, and again that pretty steady relationship regardless of concentration of the proportion of NEFA that liver was taken up. Again, it's very similar on all these other time points, and so this time point here has a star on it because it's an extrapolation, okay? But we can talk here, and we see when we look at this cow is taking up, you know, nearly 1,400 grams, right, of NEFA in the liver on that one day, right? And so it's going to be similar the next day. So the cow's liver actually takes up a lot of NEFA, you know, at the end of the day. And Heather talked that probably even in an extreme case, right, about a pound, so 450 grams or thereabouts of fat accumulation. And what you see here is even in the worst of times, right, to some extent, okay, she might be accumulating only, you know, say this much. And again, this would be probably, I think, fairly high. So the reality is she's actually metabolizing a lot of those fatty acids in some way, shape, or form, right? And so, you know, we think about this liver as kind of this receiver to some extent, but the reality is it's a very active organ from the standpoint of being able to process and metabolize, and again, not only use those NEFA for energy, but also potentially repackage and throw them back out in the bloodstream. Okay, so a lot going on there that again, I think it's regulation that's important. Okay. The other thing I added here is just this is some work that actually is currently in review. We combined we graduate students in my group and others at Cornell, where we had a bunch of data sets here where we could actually look at relationships here between BHBAs and NEFAs. And what we've got here is we've got during days 1 to 21, okay, we have NEFA area under the curve, right? So it's just a proxy for, you know, essentially a way to maybe try to triangulate in on overall mobilization, okay? So again, you know, and obviously the higher this is, the bigger that area is, the more mobilization. And then on this axis here, postpartum beta-hydroxybutyrate area under the curve, right? And so you've got this one over here, and you know, if these things were lined up perfectly, right, you'd see a very nice, tight, positive relationship here as we go forward. And the reality is, if you look here, boy, the R value is not real high there, right? So again, and this tells me anyway, I interpret this to say, you know, again, just because, you know, there's a couple different things, right? We can find examples here of animals that have very high NEFA area under the curve, yet very low blood ketones, Okay, and actually we could also, frankly, we could have liver triglyceride on this axis as well, and frankly, the relationship's not that different, right? So again, you can find animals with very high NEFA mobilization and very low ketones, maybe very low triglyceride accumulation. Similarly, you can find animals with relatively modest NEFA mobilization and yet fairly high BHBAs or triglycerides, but again, not a great relationship there. So again, back to things that we kind of stick in our minds as being somewhat dogmatic. So my contentions again are that, although again, I do fall in the camp that you can have excessive mobilization of NEFA if things get a bit out of balance. But I would contend that high NEFA mobilization doesn't necessarily dictate that cows are destined to just store all that stuff within the liver itself, right? So there are certainly metabolism that goes on in that liver, and that dictates opportunity. And I would say again, in most situations, the ruminant liver actually metabolizes the majority of the fatty acids that it pulls out of the bloodstream, and again, does accumulate some, especially during the periods of intense mobilization. But again, there is opportunity there. And then finally, I guess although rates of VLDL export in ruminants are certainly lower than non-ruminants, I think there is opportunity for some modulation of the pathways or perhaps an oxidation. And when you do those, because there is stuff going through there at probably overall meaningful amounts anyway, we can get some meaningful differences anyway in the animal, right? So again, we can have discussion there or whatever, okay? So I'm going to switch gears and switch into and talk about choline and methionine. And again, we got started on this a couple different ways. We've worked obviously on choline in different ways. Also worked certainly in the area of methionine. We pulled together Matt Waldron, who some of you know, and I, 10 years ago now, pulled together a review article, and we kind of talked about nutrients and potential for modulation and stuff like that. And methionine's role in ketosis has been speculated on for 40 plus years at this point. And again, as you'll see, and frankly, when we put that review together, couldn't find a lot of data to necessarily really hammer that one home or say that, yeah, that's exactly how that works. Likewise, there certainly are interconnections between these as Heather talked about, right? So again, choline required for certainly a number of different things, right? So aspects of fat metabolism, neurotransmitter cell membrane structure, et cetera. Methionine, certainly also required for protein synthesis, and then as a methyl donor, and can get some synthesis of choline from methionine. So there are, or at least from involvement in methionine anyway. So there are certainly some relationships there. Again, just to show choline, this is as far as the biochemistry you guys are going to get. So if you want a lot more, you're going to be disappointed. So, but anyway, so again, just think about choline again, and Heather did this very, very nicely. When you think about phosphatidylcholine, which certainly appears to be limiting or potentially limiting for VLDL assembly and export anyway, you can either get some direct conversion based on choline, or again, this trimethylation of phosphatidylethanolamin from from SAM, right? Acetylmethionine derived from methionine. So again, you see that. So again, there's different ways you can get there. So it's reasonable then to speculate there may be some linkages there, okay? The other data set we have, and again, it'd be great to do this one in dairy cattle to just see what the magnitude of relationships might be. This was done in goats a number of years ago, where they looked at methionine conversion into choline, and again, in this data set, basically, a reasonable chunk of methionine was going to choline, and it certainly doesn't go the other way, right? So again, there certainly is reasonable to speculate some relationships there. So just some thoughts here, and this is kind of what got us going in this area. And there's also, we published an article just over a year ago. I think there's reprints available too in the scientific journal Feedstuffs that was supposed to be, usually say scientific journal Hordes, right? Where's Amanda? So, but we published stuff in that scientific journal as well, and yeah, we got some stuff in Feedstuffs as well, right? But again, good source of info. So again, I think reasonable to hypothesize that there are some relationships between supplies of methionine and choline. The contention there might be is that you know what? Let's just dump more methionine in, right? If she can supply, if that can meet choline supply needs, let's just do it that way. Likewise, supplying choline might be able to either spare or provide something for methionine. And again, what I'm going to do now is I'm just going to roll through the data here, and let's walk through it together and think about what some of the similarities are potentially, and or what some of the differences may be in terms of what's going on here. So again, Rich Erdman, this is probably, I think, one of the very first studies here that was done with a protected choline source. They did, again, they looked at, and this is back, probably actually conducted in the late 80s, published in 91, looked at increasing basically feeding rates of protected choline on, at least in this case, milk yield. So you got calving over here, going out through a good chunk here of lactation, okay? And then, and again, look at here at treatment responses. And again, you got the control right here, and then you had the cows fed the increasing amounts of choline. See very nice production responses here overall, okay? So, and so again, had, and they did a bunch of work after that kind of showing more elements relative to why you needed to protect choline from degradation, why you couldn't really do it with necessarily feedstuffs per se. You needed to focus on using single source type supplementation strategies and things like that. But again, pretty nice milk yield response, okay? And that data sat there until, or that study kind of, those results kind of, nobody followed up on that until it was kind of our first study out of the gate. So we did this study actually starting, I think, in November of '98 or thereabouts, and it took us a few years to get it finally fully published. But in this study here, we basically fed either 0, and you see increasing amounts here of choline in a protected form. Okay, so this here, 15 grams here, would translate into 60 grams, this 2-ounce feeding rate or whatever of the protected product. Okay, so just know these grams here are done on a choline basis, not on a total amount of product basis or source basis. For 21 days before calving and 63 days after calving, we did provide a little bit of corn gluten meal in the diets to provide some methionine. But those of you who see this probably say, okay, well, if you put a bunch of methionine in there, maybe your lysine limit, again, hard to do methionine supplementation also without looking at single source and things like that. But I put this in there just to say that we weren't purposely trying to be methionine deficient, right? So we were trying to say, okay, let's have some methionine there, at least in some way, shape, or form, and then we'll see if there's any additional response or if choline has a benefit in that situation, okay? So again, not a real big study. I think we had 12 cows per treatment or thereabouts. Now we like to run our transition cow studies now with 30 cows per treatment or thereabouts to give us a little better power here on some of these things. But even with that, though, we saw some hints anyway for some production responses that were consistent anyway with what Erdman's group had seen. And so you look here, and again, this is the amount of stuff per head per day. We saw some trends here for, increased milk fat yield, fat-corrected milk. No significant difference in protein yield, although again, you see that would be probably economically meaningful anyway. And again, it's a trend for an increase anyway with choline supplementation on total solids. So again, we did see patterns of production response that were again, fairly consistent with Erdman's data and consistent with what came thereafter, okay? We also saw, and again, this one's not, this was not quite, you can't quite call this one a trend, but you see the patterns here relative to liver triglyceride accumulation. And again, we know that choline anyway in the monogastric is essential, or those animals will get fatty liver, and so, again, this would be very consistent anyway with our thoughts from other species and things like that, and that choline supplementation would in turn decrease liver triglyceride content. Again, not statistically significant, but you guys see the pattern there, okay? Concentration of glycogen, again, maybe somewhat of an index of carbohydrate status anyway, and in this case, we did see linear increases of that with choline supplementation, okay? So again, we did see some changes in liver composition that we overall would interpret as favorable, okay? All right, the other thing, I'm going to bring Drakely's slide back up, so I guess I owe him $2 off of this presentation, but the other thing you can do is it's kind of old, it's becoming pretty old school, especially when I see some of the stuff that Heather does, but we can still take those liver samples or biopsy that liver, drive as fast as you can back to the laboratory, slice it up, throw it in some radioactivity and say, okay, what's going on here in these liver slices? And again, It was always called the biology of dying tissue because you had to hurry and get it done before the liver, while it still remained viable. Of course, smart people like Donkin managed to figure out how to do it in longer term stuff anyway. Okay. But anyway, so we can actually look, using at least radioactivity in terms of capacities of the liver tissue from these animals to do things like, completely oxidize those NEFA to CO2. We can look at the capacities or rates at which those NEFA were being re-esterified into triglycerides and then stored in the adipose tissue itself. We can look at capacity of the liver to take things like propionate and make them into glucose. So we can do a bunch of things there to at least give us some idea of what's going on in the liver of these cows. Okay. So what we saw here, anyway, look here at the fatty acid side of this and looking at conversion of radioactive palmitate to CO2 and then the stored esterified products. We see no effect of treatment on the capacity to oxidize that palmitate, but we did see a trend for decreased basically conversion of that radio label to stored esterified products, which would be a proxy for fat accumulation, right? So a trend anyway for less fat accumulation as we supplemented more choline, which by difference, again, because it's hard to get at, and by difference would infer we had more export of VLDL, right? So again, it would be consistent with that pathway. So we started showing these results, and so Dr. Grummer gave you guys the impression this morning that it was only recently became opinionated, okay? I've known Dr. Grummer a long time, and he's been part of my formative years as a scientist and as a graduate. So I think that's fair, right? Okay. Sometimes it took a beer or two, then you really got the thoughts anyway. But Rick saw this data and said, "Oh, you're full of, this happens at such low rates or whatever." Tell me if I'm at least summarizing this correctly, okay? I guess I am putting him on the spot, but basically 2 or 3 times nothing is still nothing or something like that, right? That's about right. Okay. Yeah, pretty much. All right. Okay. But anyway, again, and it frankly is as this again our first kind of study out of the box, and we kind of went from there. But again, we'll circle back on this, right? So we also saw anyway, and again, this p-value again is nowhere near significant, but certainly those of us who kind of think about fat accumulation in the liver and stuff like that have certainly think about negative consequences of fat accumulation in the liver with things like gluconeogenesis and things like that. And again, you see at least from a pattern standpoint, if we look at propionate metabolism here, again, a pattern kind of consistent with that direction, even though we can't jump up and down about the statistical significance thereof, right? And again, this is part of the reason why we run more cows for these studies, okay? So, of course, Rick also likes telling people that he didn't believe me, so therefore he had to go do his own study, right? And so that's what he did. And so in their model in which they look at triglyceride accumulation and disposal in a feed restriction model between control and protected choline cows, again, saw very nice responses of cows for in terms of choline, not only reducing triglyceride accumulation, but also facilitating disposal of triglycerides. So there is nothing like the converted anyway, right? So and you can imagine my glee a few years ago when Dr. Grummer went to work for Balchem. So anyways, it's all good. Okay, but for good reason, frankly, because again, established through consistency of data and things like that, those positive relationships of choline supplementation on liver metabolism, on triglyceride accumulation or lack thereof anyway. And so again, showing a very nice direct effect anyway of that nutrient supply on what's going on in the liver of these cows. Okay, so let's go on here and kind of what I'm going to do now is I'm going to switch gears. I'm going to leave Rick alone and we're going to talk about just summarize some other work here feeding choline to transition cows. You got some Purdue work here where you again saw some differential responses here of choline with based on RUP supply. Did see some indication here of liver triglyceride decrease, but again, there's some kind of inconsistencies anyway, at least, or things that are again some variation response anyway within the study. Okay, this work this is done in Missouri. Protected choline supplementation increased milk yield by about 5 pounds a day. Italy increased milk yield by about 6 pounds a day, and again, had some play anyway here in things that relate to NEFA or other aspects of lipid metabolism. Okay, some work on Guelph. You guys getting the pattern here, right? So choline increased milk yield by 2.6 pounds per day. No effects in this study on blood NEFAs, ketones, or liver composition. Okay, some more work overseas anyway. Protected choline, 5.5 pounds more fat-corrected milk, 9.7 pounds more milk, decreased liver triglycerides circulating BHBA. Oops, a little typo there. Okay, so again, you guys see, again, when you start putting things together, right, fairly consistent milk yield responses. Here's more work here. Again, choline increased milk protein yield, decreased liver triglycerides, did not affect blood NEFAs or ketones. And again, protected choline resulted in increased expression of genes related to processing of fatty acids VLDL assembly. Again, work out of Illinois here. This was not significant in terms of its statistics, but again, you see that, again, similar pattern anyway response, and then, again, some production responses here from another group, right? So my summary here, again, it certainly is not a meta-analysis. I think Dr. Grummers may share some stuff that with you, but certainly, if you look at the literature, I would say pretty consistently positive effects on milk yield during early lactation. The mechanism from the studies have looked at it, at least overall, is still consistent with that improved fatty acid metabolism in liver, increased export, again, consistent as with its role as a nutrient. And I would say the effects on blood metabolites are going to be inconsistent. Okay, I think there are times when you may see some responses relative to NEFAs and/or ketones, but again, I think it's going to be inconsistent. And so, I think the most consistent responses are milk yield, right? And the other responses are sometimes there, sometimes not. I think, to my mind anyway, that inconsistent effect is logical because that choline is, really not going to be either directly anti-ketogenic, right, nor is it going to be directly anti-lipolytic. So it's not like niacin, right, that Rick showed where, that is directly anti-lipolytic, so it will drop fairly reliably or consistently drop NEFAs in the bloodstream. So again, it's not going to be as consistent a response if these are your outcome variables, but certainly see the positive milk yield responses there overall when you look at the literature. All right, so what about methionine? Hey, what about methionine? And again, I told you already that the role in lipid metabolism, liver metabolism has been speculated on for a long time. Some data back, again, a lot of focus on this in the 90s anyway, thinking about methionine and potential roles in VLDL assembly and export. Again, back to apolipoproteins and things like that. But again, a lot of that never really probably replicated on larger scale forms. But we do have some data to kind of go off here, right? So this was a study I did I was part of when I was in graduate school at Illinois, where we actually looked at a methionine source. This was it was a transition cow study before we really started talking a whole lot about at least doing experimentation specifically in the transition cow and things like that. So we had cows that were fed protected methionine from basically 7 to 10 days before calving out through 18 weeks after calving, gave them 0 or 20 grams per day of protected methionine by top dress, okay? This was, again, I'm almost at, well, yeah, I guess I'm going to poke fun at myself. This was my description of our pre-calving diet, okay? All cows are fed once daily, typical dry cow ration consisting of grass hay, 4.7 kilos per day of dry matter. So that's going to be pushing 10 to 11 pounds of dry matter. Corn silage, about 7 pounds of dry matter. A concentrate mixture, this is the part that gets good, okay? Consisting of ground shell corn, soybean meal. We're in Illinois, right? So we got to base it on ground shell corn and soybean meal, right? There were soy hulls in here too, by the way. Minerals, vitamins, and a pre-calving conditioner, right? What the heck's that, right? Anyways, blah, 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 blah. So if I had gotten this today as a reviewer, I would have bonged this paper like within at least had them revise it within minutes. So, but I'm again back to how you report stuff now versus how you reported stuff then. By the way, this looks kind of like not quite a controlled energy diet, but it's not far off from that, interestingly enough. Okay. All right. Again, looking at the diet here. Again, nothing You know, again, different specs than what I think we would be comfortable running with today in lots of ways, but again, a fairly simple diet, okay? If you look here at our production responses, we had no effect on intake, no milk yield itself. We did have a response basically in fat yields and also in fat-corrected milk. So again, about 2.5 kilos, so 6 pounds or so, give or take, of milk. And again, we didn't see, this was not significant, but no effect on milk protein content in this case. But again, showing an overall kind of yield response here with methionine supplementation. Okay, we didn't look at anything else in the study. We're only focused on the milk, basic production. Okay, cows. You know, again, some work Mike Saha did also back in the 90s and published it back in 2005. You know, showed cows supplemented with methionine and lysine beginning pre-calving had increased yields of energy-corrected milk compared with either methionine or basal. So again, put lysine and methionine together, you know, and saw some nice production responses here to those amino acids beginning pre-calving, right? So again, showing some opportunity there for some production responses with methionine and lysine. We did some work with the analog of methionine, HMTBA. Okay. Again, fed that from 21 days before calving out through 84 days after calving. Just give you guys just to see, these diets were modeled at that time with CPM dairy. These were the basal amounts of or predicted methionine supplies here. The basal was 201, and then before calving, percent of MP, 1.86% of MP post-calving. And then these are, again, the methionine levels, again, but I put in here the grams of Alamet. In this particular case, you can interpret that as you will. So we're feeding, again, these many grams, worked out to these many grams of Alamet pre-calving, or the HMTBA, these many grams post-calving here. You look at our data here, we had actually a quadratic response here. We did get a nice response. This is about, again, 3 kilos of milk there, about 6.6 pounds. And again, going kind of carried through yields of other things as well. Okay, so we did see, again, higher milk yields, especially on the middle treatment here with HMTBA. Again, we did see, you know, we went to the high level, we went back to the control. Okay, we didn't see a negative response, we just didn't see that sustained positive response. And again, you can speculate on reasons for that. Okay, but bottom line is we did see some response with the level of HMTBA supplementation by 6.6 pounds. In this case, we had no effects on NEFRs or ketones. We had no effects on liver triglyceride or glycogen. We had no effects on liver propionate or fatty acid metabolism in vitro. So did not see things, especially here, that would be consistent overall with the choline literature. Okay, again, the RIX group here, you know, looked at liver triglyceride responses to, again, the HMTBA supplementation during both feed restriction and then depletion of triglyceride during refeeding. Again, no response anyway with HMTBA supplementation. Again, unlike what they saw with the choline work. Okay. Some recent work, you know, again, looked at protected methionine with or without folic acid, vitamin B12. In this case, did not see a milk yield response. Did see an increase in milk protein content with methionine supplementation, and actually liver triglyceride concentrations actually were increased just a bit in cows fed methionine in this study. So again, saw at least some response in terms of milk protein, but not any response relative to liver metabolism per se. Ryan Ordway, again, some of his work is part of his PhD. Looked at, had a basal ration or ration supplemented with the isopropyl ester of HMTBA or protected methionine from 21 days before expected calving through 140 days after calving. So no effect here in their study on yields of milk or fat-corrected milk. You guys see the yields here. Milk protein percentage, though, was increased by feeding either the isopropyl ester analog or the protected methionine. They didn't look further relative to metabolites or liver composition in this study. And then this is some recent Illinois work, again, out of Juan Lohr and Jim Drakeley's group, where they looked at they had a basal ration or ration supplement with the isopropyl ester or protected methionine from 21 days before expected calving through the post-calving period. They did measure increased milk yield, okay? Again, you see the magnitude of the responses here, fairly large response in this particular study to the protected methionine. Didn't see any effects on NEFA or ketones, didn't see any effects on liver triglycerides, but did see some potential immune type relationships here with methionine supplementation. So again, back to not seeing, not necessarily seeing a liver, at least not a liver triglyceride, fatty acid metabolism specific scenario here, okay? So my overall summary here, again, looking at methionine sources or analog or the analogs of methionine, certainly see some positive responses in milk yield or milk protein early lactation. Doesn't necessarily appear to relate specifically to liver fatty acid and or glucose metabolism. Doesn't really appear to be associated with improved energy metabolism. So, again, maybe either our limiting amino acid concept certainly here, or perhaps an immune function, okay? So let me just kind of give you the take-homes here. And I guess I see roles, frankly, for both choline and methionine in the transition cow, okay? And I think, frankly, as an industry, we underutilize those nutrients relative to at least what's been demonstrated in terms of their potential effects on aspects either of cow performance and or aspects of what's going on in the energy metabolism of the animal, at least relative to choline specifically, okay? So again, I think they're both important nutrients, and so that's kind of what I want to leave you with there. I would say at this point in time that overall body research in transition cows is fairly large and fairly robust, I would say, for choline, and probably more so than methionine. And that's not to say that the work with methionine that's been done hasn't shown some positive responses there, because it certainly has, right? There's just probably not as much of it at this point in time. Responses to choline, again, I think fairly confidently say fairly consistent increases in milk yield. The mechanism that we can connect the dots with improved liver fatty acid metabolism. But again, if we're relying on things like NEFAs and ketones really to dictate or to be our outcome variables in terms of whether or not we get a response or not, I would say that's going to be fairly inconsistent, okay? And again, that's logical to me, just given that we're kind of at least a step away there in terms of direct modulation of some of those pathways. Response to methionine, again, increased milk yield, milk protein percentage, and potential milk protein yield. And again, probably doesn't, at least the data that are available, don't really nail liver-specific, at least not fatty acid-specific mechanisms and things like that. And again, I think certainly given that they look like they act in different ways, certainly opportunities maybe for some additivity of responses and things like that. So again, I think both important to consider, but I don't think but certainly the data would say far from interchangeable. Again, based on what we know about what goes on here. Okay, so with that, that's our new, relatively new dairy research center at Cornell. Milk about 550 cows there, and we're excited to have that capacity going forward. So again, thanks to Balchem, and I guess maybe we have time for a question or two. I don't know. So. So I think you guys, hopefully everybody heard Dr. Palmquist's kind of question and comment there, and I think again, and all valid there, right? So Don, to my knowledge, nobody's looked at mammary specific, mammary specific, what's going on there at the level of mammary gland, right? And that certainly would be an interesting area to kind of pull into more, right? Because again, certainly we see, again, back to supplementation of methionine analogs, we certainly see positive, in general, right, positive effects on performance of the animal, right? So at the end of the day, right, the stuff that we get paid for, our farmers get paid for, right? We see things that we like from that angle, right? Again, it's been hard the data would tell us it's hard to interchange these two, right, as nutrients, right? Because they certainly seem to have different roles as nutrients, and obviously that would be, that question that you're posing there would be certainly a good one to try to look into further, because it could underpin some of the, if you look at some of the meta-analyses with analogs and things like that, you would see potentially increase yields of milk and milk protein and milk fat, right? And maybe a milk fat percentage that are just slightly distinct from what you might see from, or maybe not exactly the same as what you might see with a coated encapsulated methionine source, which would be probably more specifically milk protein content and perhaps yield through that mechanism pathway, at least some of the meta-analyses I'm familiar with, right? So, no, but certainly an area that would be I think, very interesting to look into further. So thank you.
Any other
Poland,
questions?
Dave, any comments? Oh, Dave said he stopped taking choline. Says, well, have an energy drink, right? So, sorry, Dr. Grummer, uh-oh, here we go. Wait, you're the next speaker, for God's sake. Okay. So, by the way, he relishes like being last speaker so that he gets a chance to fire back. Go ahead.
So my question is hepatic fatty acid oxidation, and you implied that there may be room for manipulation of that and that perhaps small changes in that could be important. So my question is, do we have any tools for that you know of that can be used either in a experimental cell culture condition or in a practical condition?
Give it her to answer. I mean, certainly there's been some work with carnitine, right, and as a potential there. And I think some of David Carlson's work would show some, maybe some potential for those pathways to be modulated nutritionally. I think I also think that we don't have a great understanding. I probably just need to spend time with Dr. Palmquist back there, or maybe Grummer and I need to grab a beer yet. But, again, that regulation of how all the things that regulate even that oxidation standpoint, from the standpoint of total oxidation of CO2 or versus ketone production and things like that. And I think we understand parts of that, but I don't think we understand the whole deal there. Heather, you want to comment on oxidation or nutritional modulation of oxidation?
The only thing that, thank you.
It's a time-honored trick to hand the microphone to other people and let them
I would just echo what you said, with the exception of that one rodent study I shared, which showed that increasing methyl donors in the ration, and again, that was in rodents, but would increase oxidative capacity and then the respiratory chain, so the ability to convert the energy equivalents to ATP. That work hasn't been done in bovine, but part of what we plan to do. So could be that the methyl donors play a role in that. That's the only practical whole animal tool I know of for, like you said, just some other stuff in cell culture, but not whole animal yet.
Great job. Oh, here we go. This is Dr. Grummer.
Well, and I just also like to make one other comment in that you showed oxygen utilization by the liver on a weight basis goes up about twofold, 100% increase basically. The Drakely data shows that fatty acid oxidation only increased about 10% as a cow went from a dry period to a lactation. So are we losing the battle on the oxidation end of it?
Yeah, that's a good question. Nobody's really followed up also a lot of the peroxisomal work obviously was done as well, right? So we've got some different, and again, Dave Grum's work to Drakely, again, showing that maybe a significant portion of that fatty acid oxidation is peroxisomal, at least in that time frame. So there's more stuff to do there for the liver stabbers, right, in terms of work. So anything else? I think it's probably time to get Dr. Grummer up here.